Hello everyone, welcome to switispeaks official YouTube channel. This is System Verilog Essential series where we are going to learn very important System Verilog concepts which people find it very complicated to understand or they feel it's very difficult to understand. We are going to take all those concepts in System Verilog and explain it to you in very easy language. Today's topic is clocking block. Let us understand this concept in detail today. First, we will start by understanding what is a clocking block. Clocking block is basically a collection of signals which are synchronous to a particular clock. All the set of signals which will be synchronous to a particular clock are going to be present inside your clocking block. What does a clocking block do? It will specify the timing requirements between signals and clock. What are these timing requirements? I am going to explain it to you with the help of example. For now, remember, in clocking block, we specify the timing requirements between signals and clock. That's how you will be able to achieve synchronization. Another important feature of clocking block is since you specify the timing requirement between signals and clock, you don't need to worry about when the signal will interact with the clock. That is already taken care. Since the timings are already taken care with the help of clocking block, the users like verification engineers don't need to worry about the timings. It will be taken care. You just need to focus on your transactions, which are an important part of verification. Some things which you need to remember: where can you declare a clocking block? This clocking block can be declared inside an interface, a module, or a program block. These are three places where you can declare your clocking block. I repeat, inside an interface, a module, or a program block. A test bench can have many clocking blocks, but only one clocking block per clock. What do I mean? Say you have three clocks in your design: clock 1, clock 2, clock 3. You can have three different clocking blocks for three different clocks. But for one clock, only one clocking block will be present. Like one clocking block for clock 1, one clocking block for clock 2, one clocking block for clock 3. You can't have two clocking blocks for clock 1. No, only one clocking block is allowed for one clock. And you can have multiple clocking blocks. How many clocks you have? For each clock, you can have a clocking block. But for one clock, only one clocking block. Please remember, this is very, very important point in clocking block. What does a clocking block contain? You need to understand what are the things which are present inside the clocking block. Then only we will able to code it properly. Now let's understand what things are present inside the clocking block. The first thing which will be present inside the clocking block will be a clock event. A clock event is something which provides the synchronization reference for DUT and test bench. You will have a DUT and you will have a test bench. Both will use a clock. And there needs to be synchronization between your DUT and test bench, so that there are no timing violations or timing problems between the DUT and test bench. This is done with the help of clocking event. With the help of example, I will show you what is this clocking event. For now, remember that you need a clocking event and the purpose of that is to provide a synchronization reference for your DUT and your test bench. The next thing present inside your clocking block is for sure the set of signals. We said we need a set of signals in the clocking block. And what these set of signals will do? They will be sampled If it is a input, it will be sampled, and if it is a output, it will be driven. So it will be either sampled or driven by your test bench. And then you need to have certain timings relative to the clock event. And these timings are used by the test bench to drive and sample your signals. If it is an output, you will drive it. If it is an input, you will sample it. There are some very important terminologies which you need to understand with the help of clocking block. And we are going to understand that with the help of a coding example, because with the help of coding example, it becomes very easy to understand all these terminologies. This is the coding example of a clocking block. Clocking CB. Here, CB is the name of your clocking block. Clocking and clocking, this is inside which you declare your clocking block. And CB is the name of your clocking block. And we said there needs to be a clock event. So this @ of your clock is your clock event. @ of your clock is your clock event. Then there is a concept of skews, and there will be different skews for input and output. Here, if you see, we have specified some default skews. For input, I am saying let the default skew be 1, and for output, I am saying let the default skew be 2. Then there are input signals, start and data in our input signals, and output signal is data out. Let's understand different clocking block terminologies now, and we will refer the same example to help you understand. The first I said is the clocking event. Clocking event is event when your clocking block becomes active. So when does this CB clocking block become active? Whenever you have the positive edge of clock. Positive edge of clock, whenever you have this event, at that time your clocking block CB becomes active. The second thing is clocking signals. Which are the signals which are synchronous to your clock? All the set of those signals are a clocking signals. Here we have start, data in, and data out. These are my clocking signals which are synchronous to the clock CLK. Then I said we have clocking skews. Default we are specifying skew 0. If you don't specify anything, if you don't give any skew, the default skew is 0. If, say, for example, I didn't specify any skew, so default by clocking block, it will be taken 0 as input skew and 0 as output skew. And the skew can be in the form of expression or a parameter also. This is also allowed in the form of expression or parameter. You can specify your skews. Now, these clocking skews are of two types. One is input skew and output skew. Let's understand about these input and output skews now. First is input skew. Input skew means it refers to the input signal. In our case, we have specified default input skew as 1. What happens with the help of input skew? Your input signal, since it's an input signal, it is sampled skew times units before your clocking event. Since it's input, we need to sample it before the clock event. Which is the clock event? Edge of clock. Your inputs are start and data in. In this example, your input start and data in are going to be sampled one time unit before your edge of clock. This is the meaning. Now, output skew. Since it is output, it refers to output signal. Output signal is driven skew time units after the clock event. In our example, we have specified the default output skew to 2. Your output signal is data out. It means in your example, the data out signal, which is the output signal, is going to be driven to time units after your clocking event, which is passage of clock. Then we can also have certain cycle delays. In case you want a certain operation to occur after a certain delay, we can introduce those delays which are called as cycle delays. This is the operator hash hash which we use for the cycle delay. And in case you want to do certain execution in your clocking block or perform some operation which needs to be performed after a certain delay, then you will use this cycle delay. The operator hash hash operator can be used to delay the execution by a specified number of clocking events or clock cycles. Now we had seen so much about clocking block. Why is clocking block so important? For that, we need to understand the advantages which we get by using the clocking block. Let's understand these examples one by one, and once you understand them, you will know why clocking block is so important in system value. The first advantage which you get with the help of clocking block is signal synchronization. This is the main aim of clocking block. We are saying again and again, clocking block has a clocking event and the signals which are synchronous to that clock, which means it helps in the signal synchronization. Whenever you use a signal from clocking block, it is guaranteed that that particular signal will be sampled in case of input and driven in case of the output at the same clock edge. For example, in our case, if you remember, we have used passage of clock as clocking event, and we have used passage of clock, and then we had certain inputs and outputs. So it is guaranteed, if you place the signals in the clocking block, it is guaranteed that the input signals will be sampled and the output signals will be driven at the passage of clock only. You don't need to worry about it. The second advantage of clocking block is time aware verification. In clocking block, the signals are synchronized. This is one very important point. Since the signals are already synchronized in your clocking block, they can be used to write assertions, functional coverage, which could otherwise be prone to race conditions. If you don't use clocking block, it is possible that when you code assertions or when you write functional coverage, it will lead to race conditions. But if you already use clocking block, these things can be avoided. That's why clocking block is very useful in time aware verification. The third advantage is to prevent metastability. What is metastability? A situation wherein your signal doesn't have a well defined value. Say that you have a signal which can either take value 0 or 1. Due to metastability, you are not sure whether this signal will take the value 0 or 1. It can take any one of these two values. Such a situation is called as metastability. And these metastability situations generally occur near the clock edge. Why near the clock edge? Because sometimes what happens, you are transitioning during the clocking edge, you are transitioning the signal, like the signal is changing from 0 to 1 or 1 to 0 during the clocking edge. So you can miss this change. And when you are having multiple clock domains, then what happens? The signal can be transitioning to cross clock domain. It means from one clock domain to another. We call it as cross clock domain scenarios. In such cases also metastability can occur. But if you already have clocking block, you know that this signal is synchronous to this particular clock. So that time the metastability can be avoided. The fourth advantage of clocking block is test bench simplification. How does it help in test bench simplification? Do you remember where we place the clocking block? We place the clocking block in interface, module, or program block. So you can easily place this clocking block inside these test bench components, which are interface, module, and program block, without worrying about the clock. This is how it helps in test bench simplification. And then, of course, it will help you in preventing race condition. Very important advantage of clocking block. It will help prevent the race condition. Now let's understand how does it help in preventing the race condition. Clocking block has a built-in event which triggers every time a clock edge arrives. For example, in our case, the event was at the rate pause edge of clock. It means the clocking block will trigger every time your positive edge of the clock will occur. If you use clock edge directly in your sequential block without using the clocking block, if you use this directly inside a sequential block, then it can cause race conditions. But since in the clocking block, this clock edge is taken as an event. Remember, the clocking edge is an event in clocking block. By using this event provided by clocking block in your sequential block, you can ensure that the block is triggered without the race condition. If you use the event which is present in your clocking block, use this event in your sequential block, then you can ensure that the race conditions will be avoided. Why? Because in clocking block it is considered as an event. We had discussed about events in the previous lectures. If you go to System Verilog Essential series, you will find a lecture on event. In that we had discussed in detail about event. You can go there and understand about the event. There are a lot of coding examples also. In case you are confused what is an event, go to that lecture and understand about the event, and then you will know, since it's a event, you will avoid the race conditions when you use clocking block. What is the next advantage of clocking block? It helps you in handling the clock skew and clock jitter. Let's understand what happens here. Clock skew can happen when clock edge arrives at different areas of chip at different times. The same clock is going to go to different areas in your chip, and it is possible that the same clock arrives at different areas in your chip at different times. This condition can be avoided by using clocking block. Why? Because clocking block provides a synchronized environment for all signals in the same clock domain. Thus, the skew is avoided. All these signals, all the set of signals which are synchronous to the same clock domain will be properly synchronized with the help of clocking block. This is why your skew is avoided. What is jitter? What is clock jitter? Clock jitter is minor variations in your clock period. That is called as clock jitter. And in real time scenario, in your real chip, it is very difficult to have a perfect clock. All the clocks which you have in your real chip are going to have some small minor variations in the clock period. But clocking block samples the clock. It samples all your signals at a clocking event. That's why it reduces the risk of capturing a wrong value even though you have some minor variations in your clock period. Because all the set of your signals are synchronous to a particular clocking event only. Now you can understand the huge advantages of clocking block. I'll repeat the advantages once again since it's very important. The first advantage was signal synchronization. Second was time aware verification. Then we had to prevent metastability, test bench simplification, prevent race condition, and help in handling clock skew and clock jitter. With this, clocking block is very clear for you now. In case you didn't understand, go through this video till you understand this concept. It is a little, what to say, you need to understand each and every concept in clocking block to take full advantage of it. That's why, in case you did not understand anything which I explained, go through this video again and understand each and every line which I spoke, so that clocking block will be clear in your mind. To stay tuned to such content on VLSI, please subscribe to Sweetie Speaks official YouTube channel. I am going to see you in the next video lecture where we are going to learn more concepts on VLSI. Stay tuned.